Solve cotangent of the quantity 2x minus pi halves equal 1, finding exact solutions on the interval from 0 to 2 pi. The first thing I'm going to do is I'm going to think about the stuff inside the parentheses. It's an angle, so I'm just going to call it theta. And so I'm going to figure out when cotangent of theta equals 1. Well, thinking of cotangent, it needs to be positive. And to equal 1, it would need to be on a multiple of pi fourths. So pi fourths, and then also in quadrant 3, tangent is positive because it's negative square root 2 over 2 over negative square root 2 over 2. So over here at 5 pi fourths. So my solutions are when theta equals pi fourths and also 5 pi fourths, but that's just pi away, and so I could put plus pi k, and then that would cover the next solution and another solution if I kept going around or if I went in the negative direction. So this would cover all solutions, but we're interested in finding all the solutions between 0 and 2 pi, but first of all we wanted to solve for x, not theta. And so we're going to replace the theta with what it equaled, which was 2x minus pi halves, and put that equal to the pi fourths plus pi k. Now we're going to do the algebra to solve for x, so we're going to add pi halves to both sides. And then let's go ahead and combine those. So we're going to have 2x equals adding the pi fourths plus the pi halves, that's 2 pi fourths, plus another pi fourths is 3 pi fourths, plus pi k. And now solving for x, we divide by 2, and we do that everywhere to both pieces on this other side. And so our solution is x equals 3 pi eighths plus pi halves k. That would generate all solutions for k being an integer. Now we want all the solutions between 0 and 2 pi. And typically there would be two solutions if it was cotangent x, but cotangent 2x doubles those amount for solutions. Let's look at this graph, and this is our graph between 0 and 2 pi, and this line is up here at 1, and we see we have 1, 2, 3, 4 solutions there between 0 and 2 pi. So let's go ahead and list all 4 of those. I'm going to put them up at the top just because I'm out of room. I have x equals, the first one would be when k was 0, so it would be 3 pi eighths, and that was this one. Then we're going to add pi halves to get the next solution. Well, pi halves in terms of eighths is 4 pi eighths. So I'm going to add that to the 3 pi eighths and get the second solution, which is 7 pi eighths. Then to that I'm going to add another 4 pi eighths. By the way, I found this one right here. Now I'm going to add 4 pi eighths, and that will make 11 pi eighths, and that is this third solution. And then I'm going to add another 4 pi eighths and get 15 pi eighths, and that will be my fourth solution. Now if this number happened to be larger than 2 pi, and it's not because 16 pi eighths is 2 pi, then I would need to come back and see, because it would have meant that a solution here had been moved over, and we would have subtracted a period to get back to that one. But we're good where we are because we found our 4 solutions between 0 and 2 pi.